So to finish this part of SOAP services, what is left is the so-called WS star, which is everything else, right? That's easy, which goes under the name of web service extensions. So what we have said is that there are, let's say, a core part of the service-oriented architecture, which is also called the first generation web services, because it's just the first, let's say, standards that have come out, and a second generation. Now, this second generation, while the first generation has been very, let's say, stable and has grasped the fundamental tackled the fundamental problems of transport, messaging, description, and discovery. The second generation has tried to provide supports for various issues. And it's interesting, I think, this kind of structure, because essentially it has quite large degree of flexibility. So if you don't need all these other issues, transaction reliability, you can just rely on the core one and you don't need to worry. If you're for your application, you need security, you need business processes, then you can add these individual components in a relatively flexible way, not so easy as we will see, but you can do it. So this has been, let's say, done as a design decision. And what it turned out is a kind of a, let's say, very complex, I would say almost a nightmare, in the sense that in reality there is really, I mean, everybody started in specific fields to propose its own standards. Here they are kind of grouped by color: transactions, security, metadata, semantic web services, and things like that. So this is the situation in reality as it is. So there is really a plethora, a number of WS star extensions to the previous stacks, and it depends really on the kind of application that you are developing, the one that you are going to pick up. I want to show you this picture because could help you eventually, if there is the need, to select the various components. It's a kind of a hierarchical kind of relationship diagram in which you have at the center the web services. We have covered the SOAP, the WSDL, and the UDI, and then you have essentially this group of services which goes from the coordinations, which are related to the business processes, the transactions, which are related to some specific kind of application in which you need really transactional properties because of laws and accounting. There is the whole part which are reflecting on reliability and security. So it depends on the specific needs. You can browse these three and find at a various level of maturity these various WS star extensions. When I say a different level of maturity, it is that they are not all at the same level of maturity. There are really very, let's say, stable protocols, and some, for instance, reliable messaging, which I will give you as an example in the next slides. But there are some others, coordination, security, which are less stable. So that's some examples and some pointers for these examples if you are interested to go into some details. As for an example, just to essentially show you how these things work and what does it mean to extend the previous, let's say, first generation stack with the other, let's take an example, reliable messaging, which is one of the most simple on one hand and also the most stable one out there in the market. And this will follow the Earl book. You have the reference there. The Earl book is one of the books that are been, you find it in the bibliography of the course in the beginning, in the introductory lectures. So, reliable messaging is a very simple, let's say, problem. And essentially, it is something that you want if you want some kind of assurance if the messages that you are exchanging between the service requester and the service provider are really received, first of all, and then if they are received in the proper order eventually. That's the second level of things. This is something which is on top because one of the key, let's say, assumptions or philosophy of web service is the so-called loosely coupling messaging framework, which is the fact that allows the flexibility of the system. You send a message, you search for the web service, and you don't have in the standard or the core architecture no guarantees that this will be done in a specific time frame. So what it means, you don't have any quality of service assurance, essentially. So if you need this one, if you need to know if all your messages in this case arrived, then you have to have an exchange of information. And reliable messaging provides this framework. And there is an interesting, provides the things that you might imagine. The providers will be notified of the success and failure, and the message sent with a specific sequence are delivered in this sequence. There are applications in which this is important. The interesting thing is here, essentially, and that's why also I wanted to show you, it is already, let's say, this possibility is already present in the architecture of the SOAP protocol. What we have said, if you remember in the SOAP lecture, on the lecture on the SOAP protocol, we say that the majority, the typical usage of SOAP is only in the one of the two parts. There is the header parts and then there is the body part. So the standard use is the body part when you put your payload, whatever is the information calling of things or parameters, and you don't use the headers. You can use the headers, and this is an interesting, let's say, architectural point of view, to increase or to add some controls, which in this case is reliable messaging and quality control, which is related essentially to quality of service, to a particular part of the quality of service. So this is the way that is done. And what it means essentially is that, again, you're adding a layer. So that's the typical thing that you do. You add a new functionality, you need to add a layer. The only thing that you need to add is essentially that the SOAP engine, which is present already in order to support SOAP web services in your middleware, needs also to understand these extra features. So you have to add this extra step, and this is essentially the reliable messaging source, and the reliable messaging destination is put in between the messages. So it has to go from the application source and transmit it again. As an example, some simple examples are, the basic ones are that there is a concept of sequence, so you have a way in which you can number your messages, and you have a concept of acknowledgements that you are expecting for that particular package. Yes?
How much did the procedure affect the overall performance?
A little bit, in the sense that you I cannot give you an answer, a precise answer, because it depends on a number of things, but it's clear that everything that you add adds a slowdown in the overall performance. In this particular case, reliable messaging is not that much, because it's relatively easy, and you will see. That's why I also selected this example, because it's very easy to understand. It's very easy also to grasp what it is, even if in the implementation. Other kind of things in which you have transactionalities and in particular composition of services, it is performance, it's an issue. It's a clear issue. but it's just a generic issue in the sense you are adding functionalities, then there is something that you have to pay. But I cannot answer in terms of your service will be half a second slower on the other ones. It depends also on many other, as you can imagine, on many other parameters. So what you have is the typical things is this one, that your application you are adding, remember you have everything that is standard over there, which is the SOAP engine, and you are adding in your SOAP container this extra feature. And the source is sending all the messages, maybe in a particular sequence or not, and the final destination receives them and eventually sends back an acknowledgement of the message. The acknowledgements, remember, it's not typically something which is compulsory in the SOAP. You can send something without receiving anything back, or you can receive back the body, but not any information about how it went. And all this information, the sequence and the acknowledgements, we will see them in a minute as in a simple example, are put in the header, not in the body of the message. And then we'll go quickly here, but there are a number of messaging. The acknowledgement, we talked. There is the message, let's say, this is something that it's present in the support of the SOAP headers, and it's present in the reliable messaging as the kind of operations that you can check. First of all, you can check that has arrived, and that was the previous one with just an acknowledgement. Then you can check also some other specific cases, at most once. So there is kind of a contract, a promise that the delivery can be of 1 of 0 messages. So it's just some typology or types of reliability of the messages that we are going to. So retransmission in this case is not required. You just need to check if you have duplicate packages in this case. Or at least one. So there are these two different semantics. So you at most once is that at least you need 1 or 0. The at least once is that you at least it needs to be delivered 1 or several times. So retransmission in this case is required and has to be dealt by this extra layer. Exactly once, only one and no more. Then you have both the duplicate filtering and the transmissions which are required. I mean, I don't think this is so important to go into the details of this one. It's just to show you that for a particular extension, you can add a number of features to your, in this case, SOAP message. And the last one, which relates, the previous one are related to the single message. The last one is in order, because you want a sequence of packages that are delivered in order. If something, one of them is not arrived in the proper order, then you have some information that this has happened, essentially. What this how this is going to affect the logic of your application is left to the service implementation of the application, not to the protocol. The protocol just informs you if you have received it at most once, at least once, exactly once, or and in order. These are the 4 possibilities. And then what you do with it and with this information is up to the service. And this is the how it is implemented, just to show you, essentially. It's very easy. And the important thing is inside here, is in the header of the envelope, of the SOAP envelope, and the body remains whatever is the body of that particular service. So here you have, for instance, the possibility to add, when you are sending out the information, a message number. In this case, it's fixed. The majority of the times, it will be, incremented automatically by the sender. But at the end, it's going to be a single number because this is an instance of the message. And this is an example of what, for instance, you can get back from this particular protocol. You can get back information about, for instance, the acknowledgement of the range of the parameters of the messages that have arrived. So it has arrived from 1 to 4, it has arrived from 6 to 8, and so and so. So here you see that, for instance, in this case, number 5, I think, is missing, number 9 and 10, right? And number 13. So you have information about the messages that has arrived and the messages that has not arrived. And it's a sequence acknowledgement, just as an example. So that's it for the SOAP services. We are not going to go any further in the, let's say, description of the SOAP services. And if we have time in the lab, we will show you at least one of these extensions. But for sure, we will work mainly on WSDL and SOAP. Question?
Yeah, about this procedure in particular, is this implemented by default in every, let's say, web service? I mean, how do we ensure we can actually send a message?
Yeah. No, it's clear. It's clear. I think I get the question, and it's actually an important one. You cannot be sure, okay? And that's the, let's say, the easy question. That's exactly the point and also the weakness of this stack of web WS star stacks. If you want to be sure that your service is more or less compliant, I mean, not with everything, but with the majority of the, let's say, middleware implementation around the world, then stick with the standards, the low-level standards of the first generation standard, WSDL and SOAP, because that is essentially the basic. For extra features, for instance, reliable messaging, but the same can be said for security and privacy and policy, etc., you are essentially adding a layer, and so in order for your service to be used, either you engineer it in such a way that you can use it with both ways, okay? But sometimes it's complicated because if your application really relies on reliable messages, then it's something that you have to rely on, and it's intrinsic of your application. And so, because in this case, as it is, you need also to be sure that the other end is able to understand. Because this extra part of the SOAP engine must be on both ends, and must be on both ends for every of these WS star extensions. So whatever one is the one that you are using has to be point A, point B, and point B, meaning everywhere, right?
For example, would be possible to discover it through the UDDI if some web service can, I mean, has already implemented this extension.
Give you an example, which is, I mean, when you are using a service like you are using typically, I mean, an example as a similarity case. You're using Google services in the sense that you're using whatever is available on Google Docs and things. They ask you, for instance, to activate some settings in your browser for the cookies. Otherwise, it will not work. And they can do that because obviously they are very strong. They are proposing interesting services, so you do it. And the same thing is here. I mean, you are willing to use your service request or wants to use your service because you have reliable services, then you need to have also to install in your client side the reliable services layer. So that's how it goes. But clearly, it hurts a little bit the usability of your service because you are adding something and you say, okay, to your user, you need to use also this other stack. Okay, I hope I have answered. Before finishing, I have 3 more slides on different topics, but related. I need to make sure that I get the right ones. And since, yes, please.
I don't actually see the need of this reliable messaging, because if we need reliable messaging, we can assure that in the business logic of the application, not in the SOAP message.
Yes, if I get your question is, I can develop a service that uses standard SOAP messages and implements inside its logic that's for sure another possibility. So you are essentially detaching completely and putting inside your application your, let's say, needed functionalities, security, reliable messaging. Now, obviously, you cannot reuse it. I mean, this way is that if there is the reasons for this kind of architecture is to provide functionalities to you as a developer. So you need the reliability. You don't have to re-implement it. It's already there. And with already, let's say, a well-thought architecture, a well-thought conceptual model. I mean, all these rules about messages at most. So all these rules are already there, and you just can use them. So it's just a question of usability. So essentially identifying a particular kind of functionalities, which usually are, let's say, on the same scope, reliability, security, and providing these as a service. So it makes sense in the reusability, but for sure you can do it the other way around. I mean, in that way you are completely, let's say, open. You are using just the standards, and then all the things it's there.
Another question, it might be a stupid question, but
no,
for example,
no question is
using TCP for sending the messages, why do we need reliability here on this level?
Because, well, that is a different question, is that it's again at a different level of granularity. Yeah. TCP is at the level of the package, but doesn't say your message, your SOAP messages, especially if it is big, it will be separated in different packages. So reliability at the lower level is nothing to do with the reliability of the application layer. So here we are talking about the reliability of the messages at the application layer. So clearly the problem is the same, and the same the ways of solving the problems are the same, but it's a different level of aggregation. But that's absolutely clear. So since we have finished with these two main parts about the two main categories, let's say, of services, I would like to share with you one essentially table of comparison, because at the end of the day, I mean, apart from the class that we will tell you, do a REST service or do a SOAP service, in the real world, you will always have to choose what is the architecture that I'm going, what is the type of service that I'm going to do it. I mean, depend on if you are a freelancer or a startup or an enterprise, you will have different requirements. But at the end, you have to or either you have to argue with somebody why you are going to do a particular architectural decision or design decision. So I wanted to point out to you very quickly about this article, which I will upload on the website, which has been presented at the World Wide Web in 2008, and I think it's a quite interesting article by Pautasso, Zimmerman, and Lehman. Lehman Frank is a nice person, friend, who has been at the base of the proposal of another important standards of protocols of the WS star, which is one of the most used one, actually, or at least it was one of the most used one, BPEL, so the composition logic for web services. And so I want to go with you very quickly to have not really a comparison. Yeah, a comparison between the two approaches. So let's see, on one hand, the REST. So all these three slides are on the left-hand side, REST comments, and on the right-hand side in place the SOAP-based or big web services. And what they have done it in this article is they have looked at 3 dimensions: technology, protocol, and design issues. So here is a list of things that you can, I will go there through them now quickly, but essentially it's important for you to keep in mind when you have to do some of real application. So on the rest, let's say from the technology, it's user-driven architecture via rich web client application. Rich means that you're using all the protocols, all the possibilities of the protocols of HTTP. So not only GET and POST, but you're using the full-fledged HTTP protocol, which has been not used too much in the past. Few operational, many resources. URI, it's important because you have resources. You have to give a name, a unique name to every resources. It's very scalable. Well, the web is scalable. URIs are essentially infinite, and so it's very scalable and performant. So all these things are there on the right side. And distributed hypermedia system. It is. I mean, all these things is that you are using. The collection of all these things is essentially that you're using the web architecture, and so whatever is the technology of the web, you have it for granted. And about the composition, what you have is essentially what is called mashup in terms. So you have a number of services which usually are very small. They have just their resources, and then you are calling all these services as using a simple mashup. From the technology point of view, on the other hand side, so on the SOAP web services, you have orchestrated reliable event message flows if you want, okay, not always. You can have much, the very big difference is this one, because normally in REST you have a few operations. Why few? Because you have only the few commands of HTTP. So you have get, post, put, essentially, delete, okay, but not much else. While here you have the whole world. I mean, the operation is up to you, so you can you have essentially infinite operation. At the end, you don't have infinite operation. You have the one that you select, the one that you implement, but you have many operations, and typically on few resources. So the typically is a database or something which is available on the service side. There is no standard naming mechanism. In this way, here you have URI. Here you don't have the standard naming mechanism. And the focus, it's essentially on the design of integrated enterprise application. I mean, let's remember that the SOAP web services came as a necessity, or let's say as an interest of one particular type of problems, which is the integration of enterprise application. And this is reflected in the fact that the composition in the SOAP web services is mainly business processes. You are combining together something that at the end is a process for a particular application for a business. Protocol, well, we have this is probably where we have spent the majority of time, so I will go very quickly on this one. But the protocol is HTTP here, so XML, okay, that's true essentially everywhere. But essentially, the only things to say on REST is everything is going on HTTP. So it's a specific protocol, one protocol, and use this protocol at its full extent, okay? On the other hand, yes, maybe you should have written in a different order. It's also XML, but it's much, what you say is there is much strong typing. So every protocol in SOAP has its own schema, and so every document, XML document that you are exchanging in the SOAP world is validated and can be validated. It's much more strong typing, that means. And same things that we have said this many times. SOAP one of the advantages of SOAP from the protocol point of view is that it it does not only rely on HTTP. Then SOAP over HTTP is the most used one, okay? This is fine. But you don't have to have it only on HTTP. And this opens the road of the essentially, it's not scalability, this property, but evolution. So who knows what is going to be there in 10 years' time? Maybe HTTP, maybe it will be there. We don't know, probably yes. But maybe there are also other protocols. And SOAP is open to new protocols. You can integrate new protocols without any problem. Is both synchronous and asynchronous. And from the protocol point of view, there is this whole WS star stack that is evolving. Now, nothing can prohibit people to doing the same kind of things here on the REST side, but at the moment, it's true that the majority of the work has been done on top of SOAP. As we have seen, for instance, for the reliability, it is done on top, really on top of SOAP. Like you're using some extension that is already present in SOAP, the headers, to implement these extensions. So it's, in some way, it's a little bit easier to have this architecture here, even if nothing prohibits to do similar things on the REST part. Design, which is also interesting aspects. On the REST part, what you have to start doing, the first things that you have to start doing when you are designing REST is to identify the resources. So what are your resources? It's very similar, as we have said, also to the object orientation. So when you are starting an object-oriented programming application, what you have to do, you have to study your domain and identify what are the main objects, classes. In that case, here is the resources. Then you have to define nice URLs, nice meaning not very absurd and long, something that has a meaning, that could have a meaning, because it also helps the other programmer to write your application. Use in the right way, and we have seen the verbs, get, post, put, delete. And this is essentially something that we have covered in the lecture on the design with REST. It's the links between the relationship between the resources that allows you the navigation from one resource to another, and in reality then to also investigate a process. And the important things from the design, you need just a web server standard container to develop REST services, because that's all you need, right? You need only HTTP, so you need a whatever web server. You don't need any extra middleware, an important design part. Very similarly, on the other one, in place of focusing at the beginning on the resources, you will see in the exercise that we will do when we will ask you to develop a service. When you are doing a SOAP web service, the first things that you're going to do is to define the verbs, that meaning the calls, essentially, the procedure. So what is get stock, price, get book, get something, okay, or retrieve or sensor. So the first things is not the resources. The resources is probably something that is going to be in a database on your server. And but really, what is the operation? And you can have as many verbs as you want here, so you are much more free, essentially. Then the data model, the transport protocol, which you don't have here because the transport is HTTP. And here is the other design issues, that while here you can rely just on a web server, there you have to have some extra things. You have to have the web service container. So remember the difference between, please, the web server and the web service container, which is different, much more, let's say, complex middleware. So these are some guidelines in these three directions: design, protocols, and technology. And there is no real rule, essentially, on this one. Depending on your application, depending on your feelings, you have to find your way when you're going to develop this one. They conclude, and it's something that maybe it's proper, but it's not law, essentially, that RESTful, what they say is that use RESTful services for tactical ad hoc integration over the web, a la mashup. So when you have to do things, I would say like quick and dirty, it's probably the best way to go. You don't need the full-fledged. I mean, if in any case you're using HTTP as a protocol, and if you don't have stronger requirements on the terms of higher level functionalities, probably RESTful services are a good tactical, meaning that it's, let's say, easy to program and also easy to debug, and you don't need a lot of resources. You just need a typical web server, which nowadays it's something that everybody has. WS Star Web Services or SOAP Web Services is probably a good, let's say, solution for professional enterprise application. And the two things that are mentioned here, longer lifespans, meaning evolution. So something that you don't do it only for you in the next month, but you do it for an evolution. So you want to be there even in 5 years, 10 years, and maybe have it compatible with legacy systems. And there is the whole issues of quality of service. Quality of service is missing in the REST because you have the same quality of service of the web, which is quite good, okay, it's not bad, but it's, as you know, it's up to you, essentially, the quality of service of web application. Okay, thank you.